And that was Rocket by Yellowcard here on AERO Radio.
An oldie but a goodie.
Agreed. Story of young love and the story of tension in a relationship rising to the surface.
And speaking of tension on the surface, we have special guest Moritz Gustav Weber, famous of course for the Weber number.
I will never forget learning about the Weber number in Aero 302.
Amen.
Mr. Weber, thank you for being on the show.
Why, thank you, gentlemen, for having me. But my name is Moritz Gustav Weber. But you may call me Dean Weber, as I have recently been promoted to this position at the University of Berlin, where I have been working as a full-time professor in their ME department since 1913. But only now am I in charge.
I mean, that is surprising. You helped to develop the D'Alembert principle, and you worked on the motions of Halley's Comet, let alone your Weber number?
Well, let's delve deeper into this Weber number. For those of you just turning in or listening to our stream on our website, we have with us Moritz Gustav Weber.
And during the commercial break, Dean Weber helped set up a demonstration to help clarify this special ratio in fluid mechanics.
First off, we can see that the Weber number is the ratio of inertial forces to surface tension. This can be seen by my equation. The Weber number equals rho, where rho is the density of the fluid in question, v squared, where v is the velocity, L, which I call the characteristic length, which in this experiment will be the diameter of the water droplet, over sigma, which is the surface tension. In this experiment, we will be dropping the water droplet from 3 different heights. First, at 0.5 feet, which will be 6 inches in your imperial units. And we get a Weber number of 122.7. And then when we drop it from double the height, we will get a Weber number of 241.6. And then again, we will double the height, and we get a Weber number of 482.1. And so now let us begin the experiment. Now I'm going to drop a water droplet from approximately 6 inches. Now if you notice that the water droplet did not cause a very big splash, this was because I dropped it from a relatively low height. And that height did not give it time to increase velocity and therefore had low inertial forces. Now again, if I drop it from double that height at 1 foot, you may have noticed that the water droplet created a much bigger splash. Again, it had more time to increase velocity, and therefore my Weber number was larger and the splash was larger. Again, let us double the height. We are now at 2 feet. And we have a much bigger splash, in fact 2 splashes. And this created a larger inertial forces due to the higher drop height, and therefore we have a bigger Weber number due to the higher velocity, and we have a bigger splash.
Hey, that was awesome.
Mr. Joe.
I couldn't have said it better myself.
Of course you couldn't. It is called the Weber number, not the Falk number or the Dick Steen number. This would be ridiculous.
I suppose not.